All right, if you're just joining us, this is Fame Global Academy, and today we are explaining the topic called oxidation and reduction reaction, or better still known as redox reaction. We've already discussed the difference between oxidation reaction and reduction reaction. And as such, we have equations to illustrate the concept further. All right, we have an equation on the board. You can be given such equation: iron reacting with water in form of steam to form iron 3 oxide and liberate hydrogen gas. You can be given this particular equation and you'll be asked, identify the oxidizing agent and identify the reducing agent. With this knowledge of the distinction or differences between oxidation reaction and reduction reaction, let's apply it to the question as we have on the board. From this end, from iron to iron 3 oxide, this movement is what we call oxidation reaction. Why is it an oxidation reaction? Because iron has been what? Oxidized to iron 3 oxide. How did we spot out that? Looking at iron, you see that there was addition of oxygen to iron to form iron 3 oxide. And the species or the reagent that is capable of carrying out oxidation reaction or that is being oxidized is what we call a reducing agent. Why water in form of steam giving us hydrogen gas is the what? Is the oxidizing agent. An oxidizing agent is the one that causes or brings about reduction reaction. Reduction what? Reaction. How did we identify that water in form of steam has been reduced? Has been what? Reduced. Look at it critically. There was loss of oxygen from water to form hydrogen gas. To form what? Hydrogen gas. So this is how you identify an oxidizing agent as well as a reducing agent that is redox. That is what? Redox, or in a redox reaction. Like I said earlier on, for a chemical reaction to be termed redox, both the presence of an oxidizing species which is reduced as well as the presence of a reducing species which is oxidized, both of them must be present simultaneously or at the same time. I'm going to take the last example illustration before we delve into answering UTME exams as related to oxidation and reduction reaction, or better still, redox reaction. Third example, another example here. Let's look at this reaction on the board. This is hydrogen sulfide reacting with what? Chlorine gas to form sulfur and hydrogen chloride gas. Hydrogen chloride gas. Of course, if you balance this reaction, we have been 2 atoms of hydrogen here, then 2 atoms of hydrogen. Sulfur is 1, then chlorine is already 2. This is yet another question that is a typical example of a redox reaction. How do you identify the oxidizing agent in this reaction as well as the reducing agent? Now watch this progression from hydrogen sulfide to what? To what? To metallic sulfur. From hydrogen sulfide to what? To solid sulfur. You agree with me that there was loss of what? Hydrogen from this hydrogen sulfide to form metallic sulfur. This is what we call loss of hydrogen is oxidation reaction. Is what? Oxidation reaction, which is caused by the presence of a reducing agent. If you have been able to identify the reducing agent, it simply means this, of course, is our oxidizing agent. An oxidizing agent is the species or molecule or compound that is reduced or that causes reduction reaction. That causes what? Reduction reaction. How did I know that chlorine has been reduced? Because there was addition of hydrogen to the chlorine to form hydrogen. Simple ways of identifying a reaction that is redox, bearing the presence of an oxidizing agent as well as the presence of a reducing agent. If you are just joining us, this is Fame Global Academy, and we are answering question as related to oxidation and reduction reaction, or better still, also known as redox reaction. With this knowledge of what an oxidizing agent is and as a reducing agent, or what a reducing agent is, and the difference between oxidation reaction and reduction reaction. So let's attempt answering UTME questions as related to the topic. As related to what? To the topic. All right. We have a question on the board. The question says, in the reaction, this is gotten from 1981, question number 16. In the reaction, C plus 2HNO3 to give CO2 plus NO2 plus NO plus H2O. Nitric acid is acting as, nitric acid is acting as A reducing agent, B, a nitrating agent, A nitrating agent, C, an oxidizing agent, then D, a catalytic agent, a catalytic agent. All right, we have a question on the board that says, in the reaction, C plus 2HNO3 plus to give CO2 plus NO2 plus NO plus H2O. Nitric acid is acting as A reducing agent, B, a nitrating agent, C, an oxidizing agent, and D, a catalytic agent. Let's look at the question critically. Carbon reacting with this compound to form this, and this. They are not asking us what is the what? What is the function or the role of nitric acid? The first thing there is the ability to identify nitric acid. This is nitric acid. That is the common name. We call it triazonitrate 5 acid. The common name is nitric acid. What is the role or what is the function of this compound in this reaction? I just said for a reaction to be termed redox, there must be the presence of an oxidizing agent as well as the presence of a reducing agent. Looking at this question critically now, you will agree with me that HNO look at it critically. HNO3 was reduced to what? NO2 and NO. How did I actually know that HNO3 was reduced to NO2 and NO? Now, if it has been reduced, simply means it is the oxidizing is what? Oxidizing agent. Now, let's check the oxidation number of nitrogen in this compound. NO3. Nitrogen, we have +1 plus N plus 3 times minus 2 equal to 0. We have +1 plus N minus 6 equal to 0. We have N is equal to 6 minus 1 equal to 5. Then let's check the oxidation here. We have N plus minus 2 times 2 equal to 0. N is equal to +4. And then here we have N times minus 2 is equal to 0. N is equal to +2. So you agree with me that there's a decrease in oxidation number as we move from here to here. And decrease in oxidation number is what we call reduction reaction, which is what? Possessed by an oxidizing agent. An oxidizing agent is the one that is reduced, and reduction has to do with what? Say decrease in oxidation number. This is from the reactant side, then down to the what? To the product side. If you want, there's a decrease in oxidation number as we proceed from the reactant side to the product agent. A reducing agent is the one that is oxidized. Carbon has been oxidized to carbon 2 oxide. Oxidation reaction, which is characterized by who? By a reducing agent. If you are just joining us, this is Fame Global Academy. Today we are answering questions as related to the topic or the concept called oxidation and reduction reaction, or better still known as redox reaction. We urge you to subscribe to our YouTube channel. You can also find us on Instagram, Facebook, and TikTok. All right, that's how you go about this particular question. Let's take another question here on the board. We have MnO4 minus plus S2 minus plus 8H plus to give Mn2 plus X plus 4H2O. Yeah, as the oxidizing agent is, the oxidizing agent is A. We have S2 minus and Mn2 plus. B. Mn2 plus. C. MnO4 minus. Then D. S and 2018 question number 11. All right, let's look at this question. The question says MnO4 minus plus S2 minus plus 8H plus to give X plus 4H2O. This is another typical example of a redox reaction. And we are asked, we should identify the oxidizing agent. The what? Oxidizing agent. Looking at this question critically, how do you identify an oxidizing agent? Because in this reaction, we can see that some of the species, they possess charge. They possess what? Charge. An oxidizing agent is the agent that is what? That is reduced. That is what? That is reduced. So to this respect, we'll be making use of the knowledge of what we call increase or decrease in oxidation number to actually solve this particular problem. Since we are asked to identify the oxidizing agent, it simply means which agent here is reduced in this reaction. It follows that any species or agent here that is having a decrease, a what? Decrease in oxidation number, a decrease in what? Oxidation number is the species that is the correct answer to this question. Let's look at the species that is going with what we call a decrease in oxidation number. Let's take a look at this species. We have MnO4 minus. Let's determine the oxidation number of manganese in MnO4 minus. Now we do it this way. MnO4 is equal to what? Minus 1. The oxidation number of any species that is bearing charge must be equated to the number of charge or charges that it is carrying. We have Mn plus the oxidation number of oxygen is minus 2. Then we have 4 atoms times 4 equal to minus 1. We have Mn minus 8 equal to minus 1. We have Mn is equal to what? 8 minus 1, which is equal to what? 7. Now, let's determine the oxidation number of manganese at our product side, which is a Mn2 plus. The oxidation number of manganese here is equal to what? Say +2. But whereas here we have +7. Whereas here we have what? +7. If you watch here very closely, you see that from +7 to +2, there is a decrease in oxidation number, which is possessed by an oxidizing agent, or an oxidizing species. So the correct answer to this question. But let's look at this species. We have X2 minor. This is the same thing as X is equal to what? -2. Then at our product side, we have S is equal to what? 0. S is equal to what? 0. The oxidation number of any species in this free state must be equated to 0. But the oxidation number of species of any charge will be equated to the number of charge or charges that it is bearing or carrying. You agree with me that from -2 to 0, there is an increase in oxidation number, and as such, this is not correct. So that's how you go about answering this particular question. Again, if you are just joining us, this is FAME Global Academy, and today we are answering questions as related to oxidation reaction and reduction reaction, or better still called redox reaction. We enjoy you to subscribe to our YouTube channel. We'll be having live videos where we answer questions live. You'll be seeing that live, then on Instagram, Facebook, and TikTok. Let's take yet another question. Okay. We have a question on the board that says Zn2 plus we have ZnO plus CO gas heated to give Zn solid plus CO2 gas. In this reaction, zinc has been A, displaced, B, oxidized, C, reduced, D, decomposed. This is taken from 2004, question number 9. Let's look at this question on the board. The question says, zinc oxide plus carbon 2 oxide, the presence of it will give Zn plus CO2. Says in this reaction, zinc has been, all right, let's look at it critically. How do we identify or know the role of zinc oxide in this reaction? Say in this reaction, zinc has been, zinc oxide has been all right. This is zinc oxide to zinc. So what has happened to zinc oxide in this reaction? Looking at this question critically is quite very simple to answer. This is a species which is a reactant. Before it reacted with CO2, it was zinc oxide. Zinc bearing oxygen or carrying oxygen. But at the point that products are formed, the oxygen that it was bearing has disappeared or is no longer present to form just zinc. If you agree with me critically that oxygen has been removed from this compound, and the removal of oxygen from a compound, removal of oxygen from a compound is through a process called reduction. Called what? So it simply means zinc oxide has been reduced to metallic zinc, has been reduced to metallic zinc. And of course, that makes our correct option to be option C. To be what? Option C. If zinc has been reduced, if zinc oxide has been reduced to metallic zinc, it simply means that zinc oxide is the oxidizing agent. Is the what? Oxidizing agent. YCO is the reducing agent. A reducing agent is the agent that is what? Is the agent that is oxidized. Oxidized. Look at it. Carbon 2 oxide was oxidized to carbon 4 oxide. Why an oxidizing agent is the species that is reduced. That is what? That is reduced. That is quite very simple. You can also judge this based on what we call increase or decrease in oxidation number. Let's look at what has happened to zinc here now, from zinc oxide to zinc. Is there an increase or a decrease in? This is Zn plus minus 2 equal to 0. We have Zn equal to minus plus 2. Then here we have Zn equal to what? 0. You agree with me that from plus 2 to 0, there is a decrease in oxidation number, which is in line with what we call reduction reaction. What we call what? Reduction reaction. But let's look at carbon in carbon 2 oxide and carbon in carbon 4 oxide. We have just identified carbon 2 oxide as the reducing agent. So it's especially that is oxidized. So there will be an increase in oxidation number. We have C plus minus 2 equal to 0. We have C is equal to what? Plus 2. Then here we have C plus minus 2 times 2 equal to 0. Then we have C minus 4 equal to 0. We have C is equal to what? C plus 4. From plus 2 to plus 4, there's an increase in oxidation number, which is exhibited by reducing agent, because reducing agent, they are what? They are oxidized. And oxidation number goes with what? Goes with an increase in oxidation number. All right, if you are just Fame Global Academy, and we'll be answering UTME questions as related to redox equations or redox reactions. So we'll take yet another question. We have a question on the board that says, two H2O plus 2F2 gas to give 2F2 gas to give 4F2, 4HF aqueous plus O2 gas. Okay. In the reaction above, the substance that is being reduced is A, F2 gas, B, HF aqueous, C, O2 gas, then D, H2O. So this is gotten from 2013, question number 22. All right, let's look at this question on the board. The question says 2H2O plus 2F2 to give 4HF plus O2. In the reaction above, the substance that is reduced is, how do we identify the substance that is reduced? Looking at this question critically. Now, what is reduction? When we're differentiating between reduction reaction and oxidation reaction, we said reduction reaction with respect to hydrogen is the addition of hydrogen to a species or to a compound. If you look at this reaction critically, you see that this is fluorine gas at the reactant side, moving to the product side, you will agree with me that hydrogen was added to what? To fluorine. And since hydrogen was added to fluorine, it simply means that fluorine is the species that is what? That is reduced. Fluorine is the species that is reduced. Fluorine was reduced to what? To hydrogen fluoride. Reduced. Fluorine was reduced to what? Hydrogen fluoride. And since fluorine was reduced, simply means it is what? Oxidizing agent. Oxidizing agent are the species that are what? That are reduced. And the addition of hydrogen to a species or to a compound is what we call reduction reaction. If this is the oxidizing agent, simply means that this is the what? Reducing agent. A reducing agent is the one that is what? A reducing agent is the one that is oxidized. That is what? Oxidized. You will agree with me that water was oxidized to what? To oxygen. How was I able to recognize that water was oxidized to oxygen? Because oxidation has to do with what? Say removal of hydrogen from a compound. Removal of hydrogen from water gave us oxygen gas, gave us what? Oxygen gas. But what we were told to answer is that the reaction above, in the reaction above, the substance that is being reduced is, the answer is fluorine gas. How did we identify that? Because there was addition of hydrogen to fluorine to form hydrogen fluoride in line with reduction reaction. In line with what? Reduction reaction. Once again, it is Fame Global Academy. We urge you to subscribe to our YouTube channel, Fame Global Academy. You can find us on Instagram, on Facebook, and on TikTok. All right, we'll take yet another question. There's a question on the board that says, the oxidation number of and reduction reactions. The question says, the oxidation number of manganese in MnO and MnO2 respectively is A +2 and +2, B we have +2 and +4, C +4 and +2, D +1 and +2. This was taken from or gotten from UTME 2024, question number 35. UTME. All right, let's look at this question on the board. This is quite very simple to answer. The question says, the oxidation number of manganese in MnO and look at the word there, respectively. So it simply means your answer must be in this progression. How do you go about this? You have to look for or determine the oxidation number of manganese in MnO, then go ahead to determine the what? Oxidation number of manganese in MnO2 in that order or in that progression. So let's determine the oxidation number of Mn in MnO. Now, according to the rule of oxidation number, the oxidation number of any species or compound in its free state must be equated to the number of what? Must be equated to 0. Must be equated to what? 0. I take that again. As earlier studied during the course of studying oxidation number, we were told or we have learned that the oxidation number of any species in its free state must be equated to what? 0. So it simply means MnO, we equate it to what? 0. So we are looking for the oxidation number of manganese in MnO. So we have Mn plus. The oxidation number of oxygen is -2. Is what? -2, and everything is equal to what? 0. We have Mn plus times minus. We have -2 is equal to what? 0. Then we have Mn is equal to what? +2. Is equal to what? +2. Now let's determine the oxidation number of manganese in MnO2. In what? MnO2. In the same vein, we have Mn O2 is equal to what? 0. We have Mn plus the oxidation number of oxygen is what? Minus 2 times 2 atoms here equal to what? 0. We have Mn minus 4 is equal to 0. Then we have Mn equal to what? Plus 4. So the correct answer to this question is from and plus 4, plus 2 and plus 4. This is the simple way that you tackle or you handle a question or a particular question that is presented in this manner. Once again, if you are just joining us, this is Fame Global Academy, and today we are answering questions as related to oxidation and reduction reaction, also known as, or better still known as, redox reaction. You can subscribe to our YouTube channel to have more live videos on teachings as related to topics in chemistry. You can find us on Instagram, on Facebook, and on TikTok as well. We'll take yet another question. One more question. I think this will be okay for us today. We have a question on the board that says, in the reaction, IO3 minus plus 5 minus plus 6H plus to give 3I2 plus 3H2O. The oxidizing agent is, the oxidizing agent is A, H plus, B, I minus, C, IO3 minus, D, I2. 1990, question number 25. All right, let's look at this question as we have it on the board. The question says, in the reaction, IO3 minus 5I minus plus 6H plus to give 3I2 plus 3H2O. The oxidizing agent is, so we are simply asked to determine or find the oxidizing agent in this reaction. One other thing I want us to understand is this. In trying to determine the presence of an oxidizing or reducing agent in a reaction that is redox, you must identify your oxidizing or reducing species from the reactant side. From what? From the reactant side, and never at the product side. So oxidizing agent and reducing agent must be or are always present at the reactant side. At the what? At the reactant side. Let's look at this question now, as we have on the board. So let's solve for the ion in this compound. Then wherever we have ion again at the product side, let's determine the oxidation number. That will help us or guide us to identify the oxidizing agent. This is IO3 minus, left hand side, IO3 minus, we equate it to what? Minus 1. The oxidation number of any species that is carrying or bearing charge must be equated to the number of charge or charges that it is carrying. Then we have I plus the oxidation number of oxygen is minus 2. We have 3 atoms here, multiplied by 3 equal to minus 1. Then we have I minus 6 equal to what? Minus 1. We have I is equal to what? 6 minus 1. I is equal to 5. I is equal to what? 5. Then let's look at I at our product side here. We have I minus, which is equal to what? Say minus 1. From plus 5 to what? To minus 1. You agree with me that there's a what? There's a decrease. There's a decrease in oxidation number. There's a decrease in what? Oxidation number. And a decrease in oxidation number is what we call what? A decrease in oxidation number is reduction reaction. Reduction what? Reaction, which is exhibited by who? By an oxidizing agent. Which is exhibited by who? By an oxidizing agent. Did you get what I just said? That a decrease in oxidation number is what we call what? Is what we call reduction reaction, which is exhibited by an oxidizing agent. Let's look at this option. I minus. Okay, let's look at this I minus. We have I is equal to -1, left-hand side. Let's look at the right-hand side. I2 is equal to what? 0. From -1 to 0, there's an increase in oxidation number. Increase in what? Oxidation number, which is possessed by a reducing agent. By what? Reducing agent. So the correct option to this question is option C. How did we determine that? We were able to find out that the oxidation number of iodine from this species to this species was from +5 to -1, a clear indication that there was a decrease in oxidation number. And a decrease in oxidation number is what we call reduction reaction, which is exhibited or possessed by an oxidizing agent. All right, if you're just joining us, this is Fame Global Academy. Today, we actually looked at questions as related to UTM exam with respect to the concept called oxidation reaction and reduction reaction. If you are just joining us, like I said, we've been able to make an overview of the concept of oxidation reaction and reduction reaction, showing you reactions to actually explain the concept very well. And we took some UTME questions as related to redox reaction. But join us again on a Friday morning, where we'll be live here on YouTube too. That will continue answering further questions as related to redox reaction. Looking forward to see you on a Friday. And I also want to urge us to subscribe to our YouTube channel. You can equally find us on Facebook, TikTok, and on Instagram. Bye for now. Hello, sir. Mr. Phil. Okay. Hello, sir. You've been very busy.